Hello, is my voice audible? I think it's audible now. Is my screen visible now? I think my screen is visible now. Let's wait few minutes to start this contest solutions. Today contest is completely about how to grab like Today we have four different types of problems. So what we need to do is we need to solve one by one. You guys can ask any questions you have. I'm opening Q1 now. Okay, we will go a simultaneous. Okay, let's start the Q1. Okay, here I think we need to read the question right first. Okay, you are given a sorted integer array, and we need to like uh sort the okay, we are given a sorted. Okay, they also given an integer k. We need to return an array. Like in that array, the every distinct element must appear at most k times. There must not be any element with the frequency greater than k, and the relative order should be the same. So we can approach this question in multiple ways. Here the constraint is very low, so I just went with the maps solution. And the values range also very low. We can also use count array to minimize the log and order of n log n to n. I just approached this solution with just a simple map thing. Okay, without wasting the time, we just solve this basic question. Initially, taking the size of an array. Wait, let me change the size of the screen. Int n equals to a dot size. Now we need to take the we need to track the count of each element. Okay, using map. I am using C++ here. And to store the result, we need to take an result array. Okay, iterating the array one by one. What I am doing is here initially checking is the count of the current value is greater than is equals to k or not. If mp of map of it equals to k, it's already the current value stored in the result array is equals to k. So we have to skip this element from now. So what I'm doing is simply putting continue. Later, increasing the count and pushing that value into the result. That's it. I think this is the solution. Correct approach. Yeah, I will submit it. Yeah, not better accuracy. I hope we can increase the accuracy to a bit, like just by simply changing map with a counter. This is some advanced level technique, only useful when the value size is value size is less than 1 1e5, like 10 power 5 kinda. So instead of this, we use this. See, this one also work. Let's check the time con- time complexity. Yes. Okay. Okay. Not much better. Not much better. What could be the reason? Okay. Whatever the top coders used here, they didn't even use the count array. Wow. Okay, they are sorted, right? They are sorted. So we don't even use to count array. We can also just track the previous element with the current element, and we can continue with that. Okay, we take a short break and we will continue. Okay, we are back to track with a next question. Let's move to the next question. It's a password strength thing. Let me just reset this. Okay, this is a simple implementation kind of problem. What we need to do is just check whether the current character belongs to some category and update the score. If already we updated that score of the current category, we need not to update again. So we are using their frequency map there to just like we can use set there to just keep track of the duplicates. Okay, changing the name for functions. Okay, so okay, initially declaring score as c equals to 0. Now iterating through the string. Okay, initially we need to check that whether the current character is the small character or not. If wait a minute. Hello, hello. Is my voice audible now? Okay. Sorry, there was a mic charging issue. So, okay, we will continue from now. How can I check the battery of a mic? Can I check from here? Okay, no worries. Let's. Okay. We are currently checking is the current character is a small character or not. We simply removing a small character of a from the current character and check whether the count of that ASCII is within the range of 0 to 25. If the count of the ASCII value within the range of 0 to 25, then it belongs to small character. We simply increase one score to the current score. Else, if now we are doing same for capital characters, it will give ASCII value difference from a capital A. So if it is in the range of 0 to 25 with the character A, then it was completely belongs to a capital alphabets. Same goes with the small alphabets. Okay, let me adjust the screen here. I think we must completely make turn it into a coding area, like only editor, or should I show the screen? Else now we are checking is digit or not. It is a direct function. Is digit. If current character is digit, we have to increase 3 points, right? If it's digit, increase 3 points. Else, if I will create a separate set for that, map to count the track of each character. Set we will also create set for that. Set char visited and special 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 character set contains the all special characters. So every time we just need to check whether the special characters belongs to this area or not. No need to iterate like creating multiple conditions for each special character. Just sp dot find is the current iterator, like a character is not equals to special characters dot n means it found. We simply increase 5 score, right? Okay, now we check for the duplicates. If we already found, like, if v dot find it not equals to v dot n, then we simply skip this character. Else we insert it. By this we eliminate the duplicates here. Now we just simply return the score. 911. It minus here greater than, okay, here less than. Small logical error. Let's check how much we got. Oh, we are far behind from the good one, good codes. What did they do? Are they just using a ASCII character instead of sets? They just probably used multiple conditions to handle. Instead of sets, we change that into a multiple conditions. It would be a good accurate answer, but it take more time to write the code for checking multiple conditions. May down your time in little bit in a contest mode. See how many conditions they kept. Like they converted into the ASCII values and keep tracking every ASCII value, like checking the range for 0 to 33 and 0 to 64 kinda. These are the ASCII values for small characters, digits, and capital lock, capital alphabets, and special characters. Okay, our code is much better, much quicker one. Okay, I'm just resetting it. This is some tricky question, but not that much tricky. Okay, we are given an permutation. What we need to do is we need to convert into a sorted array. But operations we had is just reverse the array or rotate by left by one. Like what we can do is we can only place the first value at the last. We can't place the last value at the first. So here, when we observe to make it sorted, what we need to do is keep the zero at the end and rotate the array. We can also do is we can also keep 1 and 2 at the front and rotate, but uh, keeping the last value at the first is not possible here. Here we can only keep the first value at the last, like removing the first value and inserting it into the back. Only this operation is allowed. So what I'm gonna do is we have to like eliminate some conditions where the array is already sorted or array is rotate sorted, like it is sorted in increasing order, it is sorted in decreasing order. If array is sorted in increasing order, the number of operations we need to perform is 0. If array is sorted in decreasing order, the number of operations is we need to perform is 1. But like that one operation would be the reversing the entire array. Okay, now the in further conditions what we are doing is we need to find the wait let me explain. We need to find the split, like where the array is completely rotated. We exactly need to find that part, and we need to think of like sorting it. I will explain with a notepad maybe. Let me add a notepad thing here. Microsoft Whiteboard. Okay. Is it visible? Is my board visible? Okay, let me try this once again. Microsoft board is not working at all. What we have to do is, wait, let me add the so zonal application. Okay, I lost that application. Or we can use Excel draw. I think we can use Excel draw. I think now my screen is clearly visible. What we are doing is we take an example like 1, 2, 3, 4, 5, 6, 7. This is completely sorted array, right? Now the number of operations to make it sorted would be 0, right? So we don't need to perform any operation to make it sorted. Let me rotate this array a bit. Like we have 6, 7, 1, 2, 3, 4, 5. Here what we can do is we can simply keep these both elements at the back, which take two operations, like initially keeping 6 at the back and again keeping 7 at the back of the 6. So it takes two operations to sort this complete array, right? What could be, how can we know that? How can we know that that we need to sort like this? Again, we take another case where uh, 3, 4, 5, 6, 7, 1, 2. Here what we need to do is we need to place all these elements at the back if we go as dumb, like a basic brute force thing. So it take how many operations? 1, 2, 3, 4, 5. 5 operations. Can we do it in a much simpler way? Yes, we can do it in a much simpler way by just reciprocating it. Like we are using operation type 1, which we can reverse the array, right? Once we reverse the array, 2, 1, 7, 6, 5, 4, 3, right? So now we place 2 at the back, 1 at the back, and again reverse the array. So which take total 1, 2, 3, 4. 4 operations to sort this array. If you get this, we can use the reverse operation for our adjustments. Like we can sort the array with even like without reversing or with reversing. Reversing is completely doesn't matter. Our goal is to sort the array in increasing order or the decreasing order. What I'm trying to do is I will try both. I try to arrange the array in increasing order and count number of operations. And I will also try to sort the array in decreasing order and count number of operations. Here, if we sort the array in decreasing order, the answer would be count plus 1. If we sort the array in 5 operations, we need to reverse the array. The sixth operation would be increasing order, right? The sixth operation would be reversing the array, so we get increasing order. So our goal is to check minimum of, the final answer would be, the final answer would be minimum of count for increasing, comma, count for decreasing plus 1. So we can use this both for our advantage and we will continue with the answer. I hope the process was clear. Once we code the process, you will get to know what I am telling. Okay, I'm completely hiding the question area. Okay, first thing first, taking the size. I forgot to mention this thing. There could be an impossible way too. Like we had an array like 1, 2, 7, 6, 3, 4, 5. Whatever you do this to the array, whatever operations, how many operations you do here, it will not be sorted again. Cause here the array is not in a order. It is completely shuffled. This is a valid permutation, but it's not a valid permutation that will lead us to the answer. So in this case, we simply keep -1. We simply return -1 as the result, because we can simply identify that the absolute difference between the adjacent elements should be 1 unless it is the unless the maximum and minimum value. So you had a possible array, right? If you had a possible array, here the possible array only contains one different adjacent element. The rest of all, like I am taking an example, I am taking example as the previous one. 3, 4, 5, 6, 1, 2. Except the smaller element and maximum element, remaining all adjacent values difference is 1. If you observe that. If array is not like that, it is completely invalid to sort the array. Here all adjacents has the absolute difference is 1. Here absolute difference between 2 and 1 is 1. Absolute difference between 5 and 6 is 1. 3 and 4 is 1. 4 and 5 is 1. Except for the 1 and 6. This is the case we are using to find out the whether we can find the answer or not. Okay, if we didn't find the answer, like we didn't find any absolute difference as one except the minimum and maximum value, then it would be it would be an impossible situation. So we also need to handle that. Okay, let me straight go to the answer. Okay, initially checking ascending for int I equals to 1, I less than n, I plus plus, using flag to check is it a valid one or not. To check whether the current elements, I am using simple if condition. If array of I is less than array of I minus 1, this would leads to the array is not an increasing order. So simply make marking flag as 0 and breaking it. If flag is 1, that means the array is sorted in increasing order. Simply return 0 here. Again declaring flag equals to 1 and checking whether the current array is decreasing or not. If a of I is greater than, like a of I is, a of I must be, the new element must be less than here. Must be greater than here. So if less than here, okay, increasing here, decreasing, right? So okay, if a of I is greater than a of I minus 1, then marking flag as 0, breaking it. If flag is true, just return 1 because we need to reverse the array here if it's a decreasing order. Now we are using id. I will explain you why I am using id. Here id will just retrieve the misplacement element, like where the maximum element and minimum element was existed. Okay, or we can directly count the operation. For int I equals to 0, I less than n, I plus plus, simply make n minus 1. Okay, if a of I equals to 0 and a of I plus 1 equals to n minus 1. Here this means we had minimum element at first and max element at next. This is the case where like array is sorted in 1 7 6 5 4 3 2, like 3 2 1 7 6 5 4. This is the case we had. Here is 0 base indexing, so we need to replace elements with 0. Let me copy that case, write in that way: 0 6 5 4 3 2. Here 0 and 6, assume these both are in like this, 3 to 1. Okay, 3 to 1, assume it like that. Like 0 and 1 are 0 and 6 are adjacent, means what we can do here to sort the array, we can simply place all these 4 elements at the back and reverse the array is one possibility, or we can just simply uh, or we can reverse the array and place all these elements at the first. Okay, what we are doing is reversing is one mandatory operation. Here we must reverse the array and we place the rest of the elements at the front. We can only keep the front elements at the back, right? But here trick is we can also place the back elements at the front with one extra operation simply by reversing it. Understand? So here keeping the last elements at the first will take extra one operation, so we are choosing the minimum one between them. So what we are doing is we are just simply choosing operation equals to minimum of keeping all the current elements at the back and reversing one reversing will take I plus 1 plus 1 operations, or we can do n minus 1 we totally had here three elements, right? The total size is 7. 7 minus 0, 1, 2, 3. 7 minus 3 would be 4. So 7 minus 6 minus 3 would be 3. 3 operations to move them. Okay. N minus 1 minus I plus 1. These are the minimum number of operations we need to solve this situation. Else we can also add another case where we have array of I equals to n minus 1. Like we are having maximum element at the first and minimum element at the last. Minimum element at next goes to 0. In this case, what we need to do, like here I am also writing that case too. 6, 0, 1, 2, 3, 4, 5. Here we can't place these elements at the back, right? To place at first, we need to do one extra operation, that is reverse. So here number of operations should be same as the previous. We need to keep all at the front. We don't need to reverse. So here minimum of I plus 1 comma n minus 1 minus I plus 1. We need to take minimum of this both. OP equals to minimum of I plus 1. We just need to keep the previous elements at the first. We don't need to reverse the element because it's already in a sorted way. It's not in a reverse order. Next, for keeping the last elements at the first, we need to take n minus I minus 1 plus 1. We need to take one extra operation for reversing. Else we are also need to check the flag. Wait, let me keep the flag. A condition where it's an impossible thing. Else, if any element abs of a of I minus a of I plus 1 is greater than 1, means there is a deflection in an array. It's an impossible way to solve this. So we simply marking flag equals to 0. If flag equals to 0 means it's an impossible way. So just returning minus 1. Else return operations. That's it. 0 n minus 1 0 n minus 1. Okay, I declared flag as 0 here. We need to declare it as 1. Yeah, it's correct. Let me submit this and check runtime. Hope we get better runtime. Here 0. Okay, we just need 2 operations, right? Just keeping the last one reverse. Okay, here this is the 30 thing. 30 thing. What we need to do is 30 like big number and small number. What we can do is we need to place all the previous element at the back or back element at the first with the extra operation, right? So we reverse thing. So we need 2 operations to place this. Again, let me add that into the constraint. Here, this is the case where we are failing. We are placing 1 at the back, 2 at the back, 3 at the back. So it would take 3 operations. I plus 1, yeah, it's taking 3 operations, but n minus I minus 1, n minus 1, 4 minus 1, 3, 3 minus 2, 1. So 1 operation, what we will get, once we reverse the array, we will get like 0, 3, 2, 1. Okay, we reverse. So we need to reverse 2 times here. So here another minus 1 plus 1 would be So we don't need to place -1 here. Yeah, we need to reverse there 2 times. Okay, it will accept for sure. One wrong case. We got 0%, 100% beat. Oh, we did the best without with just order of n time complexity. We just solve the question. Okay, the next problem is the a bit challenging one. Hope you need to have some patience to understand this. This thing I didn't submit it with complete knowledge, but I I have an idea how to solve this. Initial intuition I will explain here. Let me copy this thing, copy this test case and paste this. Oh, okay. I place the queries here. Okay, I need to move here. So if you check the question, what the question states that you initially given two arrays. Listen carefully. You initially given like assume array A and array B. Also in constraint they mentioned that the maximum size of the array A would be 5. Ignore, so whatever the values in the array, just completely ignore them. So all the things remains in the array B itself. The maximum size of the array B would be, yeah, it's completely like 5 into 10 power 4. 5 into 10 power 4. So here we also have some queries like type 2 queries, type 1 queries. Here the first value means the type of the query. Okay. So initially we go with the type 1 thing. Okay. Keep it sideways. Initially we go with the type 1. Type 1 says states that you are given an L comma R comma X. What we need to do is from index L to R, we need to increment the every value with the X thing. Here we had in array B, we need to update some range with the value X. Okay. And what about type 2? Type 2 we given an total value X. So what we need to do is we need to find the number of pairs I comma j such that a of I plus b of j would be equals to that x, the total. So we need to count number of pairs. If we do manual brute force, it would take like each query, number of queries also approximately 1e5, number of array size is 1e5. If you do that, the total computation is 1e10, which is which is completely which will give completely TLE if you follow brute force. So think of such a way that we need to optimize these queries. We can't optimize Q, right? Here Q is 1e5. Order of Q star n. Assume like that. We can't optimize this Q, but we need to optimize this n, right? How can we optimize this n to find a frequency? If you think in such a way that we can cluster this b size array into some chunks like some blocks and using some lazy propagation technique, like if you aware of square root decomposition, it would be easy. If you are not, just skip this video, just go out and check the square root decomposition technique to understand this very well. What we are doing is we are computing the frequency of the required value in order of root n. So we completely changing the time complexity into q into root n. It is drastically decreasing the time complexity. If the n is 1e5, the square root of n would be approximately 100. 100 square is kind of 1e4. Or assume it like 1000 or less than 1000. 1000 into 1e5 would be 1e8. the time complexity is less than 1 in 9, so it is accepted. So we are implementing square root decomposition. It is my first time also. I am coding it as my own square root decomposition. So initially we create initially check the question. Meanwhile, my microphone was completely dead, charging it. Meanwhile, check the question, okay? Hello, is my voice audible now? Sorry for the inconvenience. My mic just got a battery issue. So hope we continue this again. Before continuing that, we are using okay. Okay, before continuing that, we are having we need to create a data structure for square root decomposition, right? What are the important thing? The main most important thing is cluster them into the square roots. So I'm doing this for the first time. Maybe it will take too much time. So what I'm gonna do is we had a value n. So we had a value n. We are doing into a square root parts. Like if we have 9, we are splitting into three parts. We have 15, we are splitting into 4, 4, 4, 4, 4, 4, 3. Like each part must be the size of a square root part of this value. Understand? Okay, when we need a value, okay, the size of block would be square root of n. The number of blocks would be also square root of n. Okay, can we do this like this? Yeah, yeah, we need to do in this kind. Okay, to get the frequency of the, we need to work on frequencies, right? So for each block, we are maintaining a map to store the frequencies. I am using unordered map for a less computation time and high response, like high accuracy. So using unordered map for each block, I am maintaining a unique, like separate unordered map also. Okay, initially for okay, I'm completely closing the question tab, renaming the queue for my sake. Q plus, what the heck is Q plus? Okay, taking the size of B. Okay, so we need to get the, okay, we are creating class sq square root decomposition class. I am creating it separately using public class public modifier to access type, to give an access type. So what I'm going to do, we need to create n blocks, square root of n blocks, right? So I will declare this as a block. This block must contain unordered map int comma int mp. It contains unordered map, so it is a block. Assume it as a block, and I don't need anything inside this. Okay, I'm declaring some int block size bz. Okay, I will declare those values inside this thing. Block size would be not necessary here, not necessarily here. So int bz would be seal of square root of n. Okay, let me test for, n equals to 10, the answer should be 4, right? If n equals to 10, the answer should be 4. Like we are creating 4 blocks, kinda unordered, map, public, or uh, oh, no, no, or D, okay, UD. Sorry, typo error. Okay, need to keep a semicolon here. The output, the standard output. Where is the standard output? Okay, I'm not printing the standard output. Cout bz. Here the output should be 4. If not, I'm wrong. Yeah, the output is 4, so it's the block size is working fine. So we need to create bz blocks. Each block must store block size of values. So I'm commenting this. Now with the block size, we need to create those many block sizes, right? So for int I equals to 0, I less than 0, I less than n, I plus plus. Okay, we must create blk object of bz blocks, bz, like we need to create 4 blocks. Okay, each thing must be belongs to the simultaneous, like those blocks. Not like this. Vector blk and block of o of, like I'm creating 4, assume size is 4. We are creating 4 block array. Each value, like bz of o of 0 contains 0th block, of 1 contains 1th block address, 1th block object, 2 contains 2 second block object, kinda. Here we need to update a frequency of each block. Okay, so what we're gonna do is BID, block ID. With the index, we need to specify which block it belongs to. We can simply do I by BZ. I by BZ will give the block address of the current block. So if I do 1 by 4 would be gives me 0. So it belongs to 0th block. 4 by 4 will gives me 1. It will gives me first block. Kinda it will work for everything. So O of BID dot map mp, I am updating the frequency of current element into the specific block. We are just creating the data structure, not yet utilizing it. So just increasing the frequency in that map. Okay, the creation of blocks is completed from now. Now what we need to do is we need to process the queries. Okay, we need to process the queries. See, I am also using the lazy propagation to optimize. If you are not aware of lazy propagation thing and uh, the segment trees, the range query things, just ignore this. Just watch this video like a normal thing. Will in future I will make a perfect videos for explaining each and everything. But for now, we are just creating. Okay, we will do in a brute force way. We are not creating any lazy propagation thing. As a beginner, I am also doing it a brute force way. So we need to process each query, right? For auto itq, okay, in type equals to it of 0. So what type of query it is? It completely depends on wait, int l comma r comma x. Okay, if type equals to 1, we have three variables: l equals to it of 1, r equals to it of 2. We need to increment the value in the range l comma r, right? With what value? X equals to it of 3 with x. Else in type 2 we are only aware of x, right? It of 1. Okay, now what we gonna do? We need to update in the range l to r. To update the value in the range l to r, what we gonna do is okay. For now, what we gonna do is to range update the values from l to r. Okay, we are creating separate function l comma r comma x comma. We are also passing the object o, which contains the blocks. We need to update those frequencies. Next, we are querying it. Like, what we gonna do is we need to query for each value in array A. The required value would be x minus it. We need to find number of elements c plus equals to q of c plus would be q r y of, we are passing object, we are passing k. We need to find the frequency of this k. Also we need to pass block size, it's mandatory. Okay, also, okay, that's it. We also need to pass block size here too, comma bz. Now we are here we need to, in result, we need to push the answer, push back answer as c. That's it. We done with the coding part. We need to code those two functions, update and query. push. Sorry for the typo errors. Result update. Okay, we need to declare that result vector int rs. Okay, here we are initially doing update function int l, int r, int r. Okay, vector blk ampersand o, int block size. With these things we need to update. Okay, we also had value x, right? Yeah, x before l and r, int x. So what we need to do is int l block id would be l by block size, r block id would be r by block size. For int I equals to l plus 1, I less than r minus 1, we also need to pass the array here. What is the array? B, right? Comma B, comma vector int ampersand B. So within the range, what I am going to do, I will explain here. So what we have up to now, assume we have block 1, block 2, block 3, block 4, block 5. Our L is in block 2 and R is in block 5. So we gave a command to update from L to R, like increase the value to +5 in every value in the range from L to R. What we gonna do is we simply ignore every value in this. We just do +5s here, and we gonna do manual +5s in this L2 block end and R block start to R. The rest of the updates would be on array. So for query we are optimizing it. For updation we are doing it in a brute force way. Still we get a problem. So really need to switch here. We really need to switch into a lazy propagation technique. It's mandatory here. Instead of updating each block into +5, we need to do it manually without lazy propagation. If there are 1,000 values in this block, we need to iterate everything and increment +5 there. So without lazy propagation, it is impossible to do that. So we need to use lazy propagation here. So I am also creating some, what would be my lazy value? Int LZY equals to 0. My lazy value for my block is 0. Okay, I'm also using this. Now L plus 1, R minus 1, I plus plus. For these blocks, I am just implementing var5 dot lzy plus equals to x. I am not incrementing each and every value. I am just incrementing the lazy value. I will update this for sure in upcoming times when I am really need querying things. I will update that. So what about the block L and block R? We are doing that now. We need to update update the blocks carefully here. For block LB, like for block LB, we need to update those values to, like, we need to update the lazy functions. So what I am going to do is I will explain here. Here, assume we have some blocks. We have some blocks here. Forget about lazy. Just know what it is doing. We have lazy +5, lazy +10 here, lazy +5 here. Now I want what is the current value of I inside this block. So what we need to do? Initially, we need to update every value with this lazy operations. Like we need to increment +15 for every value and then proceed for checking what is the value of I. So what I'm doing is initially do all pending updates. Like what are the updates I need to process? I need to process that first. So here processing update of block LB of block LB. What are the values? What are the left value and right value? Int I equals to bz star LB. Is this would be what I'm trying to access is the starting value of the block I. If assume this is a 4 by 4 updates, like 0 to 3 would be here, 4 to 7 would be here, 8 to 12 would be here, or like 11 would be here. So what is the value of this second block? 2 star 4, right? No, like 5 by 4 would be 1, 1 star 4. Yeah, I star 4 would be the block starting point, and 4 plus, next 4 plus 4, 8. Like LB plus block size would be the ending value of the current block. So we need to iterate from start for int I equals to bz star lb I less than bz star lb plus lb. Or we can do like lb plus 1 star bz. Okay, it will give the next block starting address, right? And I plus plus, we need to do pending update. Okay, first initially remove the frequency of current thing into the in the array, like o of lb dot mp of b of I minus minus b of phi plus equals to o of lb dot lazy. Now what we need to do is increment the o of lb frequency, lb dot mp of b of I plus plus, removing the old value and incrementing the current value. Do this same thing for the R block also. Okay, again I equals to bz star rb. I think it would be easy if I create a different function for it. Void prc process vector int ampersand a vector blk ampersand o comma int block lb. So what I'm gonna do is I just simply copy paste, control X, cut this and paste this here. So instead of repeatedly coding the same thing, we can just simply we need to pass the block size too. Yeah, int bz block size, block size. Okay, everything was good, right? Up to now, lb was passed, block size was passed, object was passed, array also passed. So process, what are we passing? Array, object, and block size and block, right? Block lb comma block size, ampersand ampersand. Yeah, it will give me updated blocks. Also process same thing for array o rb comma block size. It will process for both l and r blocks. That's it, updation was done. Now we need to do, what we need to do is we need to code the query function. In query has some unique, first initially while processing queries, before doing queries thing, yeah, we can also do queries, the optimizer one. We can also optimize these queries, right? Yeah, We can do it in a very optimal way. What we give is O, K, and block size. Vector block ampersand O int K, the element we need to find, and block size. So what we need to do is we simply need to find the count in each block. Int count equals to 0. For int I equals to 0, I less than block size, I plus plus. So there is a lazy updation would be in every block, no? So what we need to find is, yeah, I will explain what the catch here. Current block had values like 2, 3, 4, 4, 2 fours. Okay. We need to count the number of value 2's in this block. Here we have lazy propagation updation 2. Sorry, number of 4's here. We need to find number of 4's here. Here we didn't perform this plus 2 actually here. So what we need to do is we need to find 4 minus 2. We need to find number of 2's inside this block. So after performing that operation, so it will simply gives the number of 4's after this operation. So instead of getting directly 4's, we are getting counts of 2, which would be the current 4. Current 4. We didn't update the values yet. So the actual value of 2 would be 4 after updating, but we did lazy operation here. So we didn't update the current value of 2. So it actual original value would be 4. But as representation, as time complexity, we just updated it as 2. So what we need to check is k minus object of lazy. We need to check a lazy value in every block. That's it. This is the catch we need to handle. So C plus would be O of LB, O of I, O of I dot MP of, in that map we need to find K minus O of I, O of I dot LZY lazy. After updating that, simply return C. Let's check for the errors. Yeah, B. Where is B? Okay, here we passed A and calling it as a B. So we make it B. Oh man. Okay. There may be some logical issue. We need to find it out. Every answer was wrong. Okay. Array is not updating clearly. With this, we can say update operation is not performing well. Let's check for this. So initially 2 comma 5. We need to paste this thing here, not this. For this, the answer should be 2 comma 4. Yeah, debugging is the best part in average coder style. Yeah, I pasted the test case. So what would be the queries? The initial values are 3 comma 4. When we check for the total sum of 5, 1 comma 2, what is 1? Like 5 minus 1 would be 4. Number of 4's, only 1. And what is 5 comma 2? is 3. Yeah, again we found one 3. Now what we updated like 0 comma 0. In this range we added the value 2. So is that value added? After every update I need to print that array. Okay. Okay, after every update, let me print the array first. To be see out. I think updates would be fine, but block contains 343434. Man, it's not updating. L comma R, where are you? What is LB and RB? See out LB RB. LB and RB would be 0. LB and RB would be 0. Yeah. Initial update. LB and RB. See out I. This for loop is not retracting, man. Yeah, I think I no, it was iterated. It was iterated from 0 1 0 1 two times. Okay, I forgot to remove lazy. OB of LB dot LZY equals to 0. Will this solve any issue? Even though it's not working, it's not updating the values. What is the lazy again? Okay, we are updating with the lazy. Actually, we need to add the value x also here. Yeah, this is the thing we forgot it. Okay, print your need to update plus x. Okay, let me test it right now. Okay, here we are updating two times. Yeah, two times it will get updated. If if RB not equals to LB, then only process this again. Okay, one good case, one good case. What happened here? I only updated from 0 to R, right? Not every value need to get updated here. Okay, now I get it. This process should be in a same array, not a separate function. Only this function was missed, right? I will make sure this works. Okay, first. Okay, I will make it. Now I get it. I just updated lazy here. I forgot to update the query X. So lazy wouldn't be any problem here, even though we recompute two times. So after computing lazy, if LB equals to RB is case, like both values belong to same block, else these are the two values. Okay, so If LB and RB are same, for int I equals to L, I less than or equals to R, I plus plus, just implement a normal, like, current block is I by BZ, O of current block dot MP of B of phi minus minus B of phi plus equals to X, O of current block dot MP of B of phi plus plus. Okay, this is the manual updation. It will work if this both are not belongs to the current block. For int I equals to L, I less than LB plus 1 star BZ, I plus plus. Okay, what we need to do is same, int current block equals to I by BZ, O of current block dot MP of B of phi minus minus B of phi plus equals to X, B of phi plus equals to X, and O of current block dot MP of B of I plus plus. Now increment block B for int I equals to RB dot BZ, I less than or equals to R, I plus plus, same thing again. In current block equals to B by equals to X, same thing. Just copy pasting. Now let's check how the code works. Process, yeah. In process we don't need to pass value X. We are removing it, right? Hmm. Taking too much time. Yeah, it got accepted. Will it take TLE? Will it take TLE? Then I would be taking too much time to code this. Okay, some kind of address errors. Block address was not found. Of I. Okay, here LB plus 1. Here RB. Okay, let's check run this again. All green. Submit it. Any other errors? Where was that error from? LB. Why I am using LB here? Genuinely, why I am using it? Can I make a BZ plus one extra block for some space constraint? Use this test case. Let's check this again. Still same error. Somewhere I'm printing something. Okay, for everything I'm printing this, right? It will also give us 12. Okay. In process. In process we got error. Okay. We also use same thing, current block equals to I by bz, we use cb as a thing, cb, and update here cb. I still worry why LB not work. Why why does it didn't work? I wanna know what the CB was. MP of B of 5 minus minus, was that an issue? O of CB of MP of B of 5 minus minus, was that an issue? Let me print where that CB is giving me errors. Current block. Oh, why 2 was an error? What is the size of the array? 1, 2, 3, 4, 5, 6, 7, 8. 8 square root of 8. 2 to 4. 3 is 9. 9. So the size would be 3. What error I get? Oh, MP of B of I minus minus. What if I comment this? Will I get error at down? Why I am getting error here? What was the query again? For which query I am getting? So processing would be here, right? So 1.7.766. So 1 to 7, I'm incrementing the values, like seventh value we are incrementing, right? So a single position. So what would be the block? 7 by, what is the block size again? 4. So it would be 2. There are 2 blocks. No, there should be 3. What is the block size? Let me print everything. Block size is 3. So I have 3 different values, like 3 blocks, 3 containers. In that, the 7 would be placed in second container, isn't it? 0, 1, 2, 3, 4, 5. It should be placed in third container. Why that much mistake? L and R would be 7 comma 7. Block size would be 3. 7 by 3 would be 2. Okay, 0, 1, 2, third block. Yeah. 2 would be second block. Yeah, third block. Yeah, it's going to block 3. In update process, we have array B, comma object O, and 3 comma 3. 3 comma block size 2. Okay. Yeah, it won't be performed. Let me check. Cout pp. It should not get output pp. LBZ or okay, no pp. So no that loop working. Now we need to check why process is got scared by LB. We just use simple map. Why? Okay, map issue here. Could be map issue. of cb dot lzy. I'm printing the value of lazy. Let me check what is the value of lazy here. Huh? What the heck? Value of lazy is 0. Okay, yeah, lazy would be 0. Let me just iterate through the map for auto it of lb dot mp cout it is to first. Iterating through the map, nothing much. Will this raise an error? No error. Man, we have 114 value, 115 value, 1623, 14, 15. How this could be? 7, 14, 15, 16, 23. How did they get 16 and 23? How could be? Thus I am iterating array A or B. Did I pass array B right? Yeah, array B. Everywhere array B here. Update array B. Let me print this thing also. Where the hell I get the frequency of 23 and 15? Why didn't I have these values? Okay, ignore that. What is the block 2 again? 0, 1, 2. Like block 1, block 0, block 1, and block 2. 14, 7, 14. Here the value should be 2, right? Yeah, am I checking the card case? Printing the values of this. Before crossing lazy, I must get everything as 1. Everything as 1 there. If I if I create this on my own in a contest, I would be probably fail to solve it. why I am not getting MP of 5. Why? Okay, let me ask this. What is the error here? Oh, what would be? Okay, B of 5 is invalid. Yeah, I forgot to. I forgot to do that. Okay, okay, now I get it. And I must be less than B dot size. Here the problem not within the array, not within the map. It's in the B array. Okay, let's comment all those shit. Oh man, how dumb I was. I'm creating block without caring about the size of the array, man. Okay, I think it will work now. Yeah, fine. Did I comment everything perfectly? Yeah, commented it. No, another error. I can't tolerate one more error. Really? Wrong answer? Doing some mistake at somewhere. Bulk, count, incrementing, lazy dot zero. Why current block with LB would be fine. Last one must be 2. LB. Man, I give up. I must use this test case to find out whether I was right or not. Still I miss something. Yeah, still I miss something. My output still upgrading it, like still incrementing some boundaries. That not what I want. Result. If L equals to R, one base indexing, right? 0, 1, 2, 3, yeah, one base, no, zero base indexing. I equal to L, I less than, I equals to, yeah, this update doing well. What is the last query? 2 and 191. Okay, think no logic mistake is here. Okay, we are not in one more some silly mistake. I less than RB minus 1. I kept like RB minus 1 here. I less than RB would be enough. Yeah, a few kinda typo errors. Really. What the heck? Do we still need to optimize it? Where should I optimize it? Where should I optimize it? For every lazy operation, I am doing this. For L and R equals to uh, RB. If O dot LB O of some optimizations dot LZY equals to 0 written some optimizations pass this. Or maybe we can change it now into unordered map. Runtime error. Okay, okay. Okay. We need to use long everywhere. That's it. The code went well. Type. Yeah, unordered map is the technique here. We need to use unordered map everywhere. We need to convert every integer into long. That's the main shit like here. LL long. Block size would be a normal integer would be sufficient. Okay, lazy is long. Everything was long. Int L R X should be long. Block size okay. Here block B would be long, and rest of the processing was okay. Int query int okay. The C would be the count would be okay. Normal thing was okay. Normal counts. We will typecast it into int. We will pass BL. We create B vector LL B of BL dot BG and begin comma BL dot N. Okay, now we will check BL dot size. Sorry, typo error. I wish it could work now. I wish one more TLE would be a for broking. Yeah, finally solved. Somewhere at last. Man, how did you solve this with this logic? Another map, long, num name. Yes, probably square root decomposition. Everyone's doing the same, but optimizing the LOC. That's it. Yeah, This is the code with small struggles. That's it for today live. Okay, see you tomorrow. Bye bye.